here we go. So we have this function. You should recognize this is exponential y because x is the exponent. In particular, you can rewrite it if you want. Right? If you want to rewrite it as a decimal, that's fine. So immediately we know a couple things, right? If this is between 0 and 1, we know that this is what's going to happen, right? It's a decreasing function from left to right. We've got our asymptote here. That is actually the line y is equal to 0. When it's a logarithmic, what is it? X is equal to 0 is the vertical asymptote. Anyways, is the function increasing and decreasing? It's decreasing by how much? I will explain. Because b is between 0 and 1. Okay? And by how much, I will just figure it out. 1 minus 0.75, that's 0.25. So you can say 25%. We don't know what the units are for x, so per unit, right? 25% every time. That is by how much? State the y-intercept, that'd be 0.50. That is simply that value right there. The x-intercept, none, not applicable. Something like that. There are no x-intercepts. It just will never cross. Okay? Never crosses. Okay. State the range of the above function both ways. So for range, it would be y is greater than 0, right? Set notation. Or you go 0 to positive infinity like this. So I'll give you half mark for each. State the half-life of the above function. How do you do that? This is very important. Half-life, so half of what you started. So sometimes I like to do this. y2 is equal to 50 divided by 2, so you know where I got that value from. And if you do that right, you get 2.41. Right? So x second trace 5 intersect, so I will just put that right here. X is equal to 2.41. And we don't know what the units are, so it could be years, minutes, seconds, we don't know. The equation of the horizontal asymptote, I just gave you that. That's y is equal to 0. State the quadrant activity. So this goes from quadrant 2 to quadrant 1, or quadrant 1 to 2, it doesn't matter, it's the same. What other type of function has the same quadrant activity? Be specific. I would say a quadratic, right? A quadratic function, but be very specific, with a positive leading coefficient, okay? Or positive a value if you write out the equation, right? Ax squared plus bx plus c, I want that value to be positive, okay? So that's when I know it's going to have the same. And if you do this, right, even if it crosses down into the other quadrants, the ends are quadrant 2, quadrant 1, okay? Change the equation so that it decreases by 1.5%. So we're going to do that. So you basically go 1 minus 0.015 to the x. Technically that is good. Technically you could leave it like that. I would like to see, what is it, 0.985x. Okay, it's hard to see, but it's 0.985. So you take away 1.5%, turn it into a decimal, take it away from 1, and then you got it. I would say 1 or nothing. So here we have an increasing exponential. It's an investment made. Use the information to answer. What does A represent in this case? A is 5,000. It is the initial amount of money deposited, amount invested. Right, in this case, it's the initial amount invested. B, right? it tells us that the investment grows, okay, by, and you can do the math there, 2.5%, right, per year, because it says every several years there. So investment grows by 2.5% every year. The domain of this scenario, so you have to imagine, right, this is a word problem now. So we're starting somewhere on the y-axis, and then we're going up like that. So for the domain, it would be from time 0 to infinity. That would be my domain there. The range for this one, oh, it wants set notation. I don't care, because the province won't care. Like, you get to choose which one you want to answer with. Whether or not they give you set interval or set from a multiple choice, that's different. So set notation, help me out here. X is greater than or equal to 0, right? That'd be the set notation. Either one is fine. Interval for the range, you go as low as 5,000 and it goes to infinity. That's like me. Yesterday I was watching a show with my wife and I was doing that and she got really upset at me. No, it's okay. That's the beauty of goldfish, right? Okay, state doubling time of this function. So doubling time, y2 is equal to double of what you started with. So in this case, we double that, so that'd be 10,000. So when will you have 10,000? 28.07 years. I go second trace 5, of course. And I need you to understand. Are we good with this? Is that what it is? Yeah? Okay. You might have to adjust your window to make the line cross like that exponential. But one thing I need you to understand, you start with 5,000 and you're doing a 10. Listen carefully because this is going to come back later. After you find this, you're guaranteed to double your money every 28 years. Okay? So if another 28 years go by, you will go from 10,000 to 20,000. Another 28 years go by, you'll go from 20,000 to 40,000. So your money doubles every 28.07 years. That's what you're actually finding. Okay? And because this curve goes up like this, at one point it's really steep, right? The money amount is always higher after every doubling period. Like the amount you have is going to go higher every time. How much money was made during the first 2 years? We'll just go y2 is equal to, no, sorry. They give me time, right? They want the money, right? Because we know, based on this, x is time, y is money. So we got to go second, trace, value, x is equal to 2, y is equal to 5,253.13. That's how much you have after 2 years. But how much did you make? Yes, you gotta go 253.13. So I'll give you the mark. I'll give you 1 mark if you have the 53.13, because you're definitely showing me that you know what needs to happen. And we'll give you another mark for coming up with the 253.13. Did I give you 2 marks elsewhere? No. That's it. So this is worth 16 because me giving you 2 marks for this part. Name and last name. And if you have questions, please.